Hello, welcome to In 5 Minutes. We have done with the DC analysis of the MOSFET. Now coming to the AC analysis of the MOSFET. You know we have already done the AC analysis of JFET common source, can say N channel JFET common source amplifier. The analysis of N MOSFET common source amplifier is same as the analysis of N JFET common source. What we are doing, whatever is done for N JFET is similar to N MOSFET. So what we are doing, we are going for common drain, which is called as a source follower. Now what do you mean by source follower? The output, you can say here this terminal is your source terminal, or you can say this is your source, this is your gate, and this is your drain. You can say where is the input applied? Input is applied to the gate, and we are taking output from the source. So which terminal will be the common? The common terminal will be the drain, hence it is called as common drain amplifier. Now it is called as source follower. Whatever is applied at the gate will be followed by the source, hence the name source follower is given to this, right? Now what we can do in this case, suppose say a problem is asked to calculate the small signal voltage gain of source follower circuit, in which all these values are given, and whenever you say the lambda is given, that means you need to consider the value of small r-o, right? The formula to find small r-o is lambda into IDQ inverse. So for this we need the value of IDQ, and the value of IDQ we will get from the DC analysis. So what we do for the DC analysis, we draw the circuit under the DC operating condition. That means we remove the capacitor, so this part will go. So you are left with R1, R2, your NMOS, you have plus VDD and RS. Now the formula to find IDQ, you can say, start with the solution. You know IDQ is for N channel Kn VGS minus VTN the whole square. Now we don't know the value of VGS. We can find the voltage at this point as VG. How? This R1 and R2 is given in the question, and this is nothing but your VGS. We can write VGS as VG minus VS. How we can find VG? Voltage at this point, this terminal is grounded, so I can say by potential divider rule VG is R2 upon R1 plus R2 multiplied by VDD. So this will give me the value of VG. So once you know the value of VG, you can find the value of VS. How? The current flowing to source is IS, which is nothing but the drain current ID. So I can write VG, instead of VG I will write R2 upon R1 plus R2 into VDD minus ID into RS. So instead of VGS I can replace this term in this equation. So what I will get, the value of Kn is given in the question, the value of VTN is again given in the question. So these two values you know. You don't know the value of IDQ, you don't know the value of VGS. So if you have a single equation and two unknowns, you cannot find the equation. So what we are doing, we are expressing VGS in terms of IDQ. Now in the question you can see the value of R1, R2, that is this R1, R2, and VDD is given, value of RS is given. So what you will have, you will have one equation in terms of IDQ. So your equation will be IDQ equals to Kn is given as 4 milliamperes, 4 into 10 raised to minus 3. Instead of VGS I will write R2 upon R1 plus R2 into VDD minus ID into RS minus VTN is given as 1.5 the whole square. So when you will solve, you will get the value of IDQ as 7.97 milliampere, and from this you can find VGSQ as 2.91 volts. So these two values are required in the AC analysis, which we'll get from the DC analysis. Similarly, we had done in the AC analysis of BJT also, we find the value of ICQ to find the value of RPi and GM. Similarly, we are doing DC analysis over here. So in this question, for the problem, you will get the value of IDQ and VGSQ in this format.